Hey, it's me, Neil, again, your friendly neighborhood data guy. And today we're going to talk about AI categorization. AI, or machine learning, has long been a tool of analytics. Just think of any kind of forecasting, whether it be quarterly financial forecasts or something more down to earth like predicting which Google ad or YouTube video or Spotify track you might want to listen to next. But generative AI tools like ChatGPT and CoPilot have opened up a whole new horizon. You may have heard of this new AI concept called vibe coding. The idea is that you can develop new apps, games, websites, or whatever just through prompting a generative AI platform like ChatGPT or Copilot. Tools like Cursor AI, IntelliCode, Kite, and Replit Ghostwriter are a few of the more popular tools for accomplishing this. This approach works well for new apps or websites. I like to take a vibe coding approach to writing Excel macros and occasionally SQL queries, although I usually just interact directly with ChatGPT or Copilot. That said, this approach is not without some risk. For example, this coder found himself in hot water after he realized the generated code had exposed all sorts of secrets like authentication keys. In my limited experience with using AI to assist with coding, I have found that it is excellent, nearly magical if I'm creating something brand new like an Excel macro. But once there's code or other constraints in place, these tools begin to struggle because they make so many assumptions. When we're performing business analytics against data sets, it is difficult to make assumptions about the quality and integrity of data. Even the cardinality relationship between tables can't be known until you profile the data, and you might have to perform some intermediate cleaning steps to remove duplicate keys. So using AI against a naked data warehouse or lakehouse is particularly risky. On the other hand, tools like ThoughtSpot, which allow you to describe in plain language your query, can and do work well, but are constrained by the underlying semantic model. A semantic model is what business intelligence tools use to support interactive analysis in dashboards and reports, but these models are all imbued with a particular perspective. So, for example, as a sales dashboard might allow you to see sales revenue by month or sales region, but if your model doesn't include date level or postal code level detail, or perhaps it doesn't break out sales by product category, in these cases, you're really limited to asking questions just involving months and sales regions, and that's about it. In other words, the best we can work with is within a limited set of categories. If we cannot reliably use AI to query a raw data warehouse or lakehouse, and if we are limited by the set of categories a semantic model can provide us with, then this gives us a clue as to where AI can most effectively help us. So what this tells us is that the sweet spot for AI with respect to analytics is to help us create categories and assign those categories to things that we are interested in. But there is another clue that comes from history which also points us in this direction. A few months ago, I made a video explaining how analytics works and explained how the origins of logic can be traced back to the 4th century BC in a book called Prior Analytics, which is where Aristotle first describes the Greek syllogism, as in, all people are mortal, Socrates is a person, therefore Socrates is mortal. In order for a syllogism to work, you need to link up and compare categories, such as being a person, which is a big category, or being mortal, which is a bigger category, not to mention Socrates himself, which is also kind of a category. But what is most clarifying to me is that Aristotle's 6 volumes on logic, which include Prior Analytics as the 3rd book, has categories as its 1st volume. This book essentially enumerates all things that can be, well, put into a category. Here's a full list of the categories, starting with substance being the primary category, with all other categories being secondary features of substance. So here they are in order: substance, quantity, quality, relation, place, time, position, state or having, active action, and then finally passive action. So building on this notion of a category, Aristotle eventually led to the syllogism, which you can think of as a formal way of comparing and contrasting categories in order to reveal new insights. Interestingly, categories, unlike Prior Analytics, was never lost during the medieval period and was one of the first books to be translated into Latin by Boethius, arguably the last philosopher working in the Greek tradition. In fact, medieval scholars were kind of obsessed with categories. For them, it was the only way to reason. The main difference between then and now is that we simply have more categories and are more flexible with our definitions. We also tend to be a bit more oriented around the 5 W's categories, as in who, what, where, when, why, and sometimes how and how much. But if you think about it, what we are doing here is not that much different from what Aristotle was describing. And the reason I bring all of this up is that what this tells us is that categories are essential to logic, analytics, and reasoning in general, and in fact transcend technology, mathematics, and yes, artificial intelligence. So where do we go from here? Before jumping into the demo, I should point out the reason it is safer to vibe categories than vibe analytics is twofold. First, AI categories are easier to validate. Once the AI has gone through and performed its categorization, you can then easily validate the correctness of this categorization through some basic random sampling. You only actually need to check about 15 category assignments, and if all of them are correct, you can proceed with some measure of confidence that the AI categorized the entire population more or less correctly. If not, you can try refining the data you send to the AI or refining the prompt. Rinse and repeat until you're confident that the AI categorization is fit for use. Second, categories are modular and can be used with other categories to answer a wide range of questions. Once you have a valid set of category assignments, you can now have what I call a Lego block that you can mix and match with other Lego blocks like dates or regions or what have you to reveal otherwise hidden insights. In other words, categories have a kind of a force multiplier effect. In this demo, imagine we are a retail analyst and we're trying to settle this debate. How much sales and marketing budget should we allocate to our regular shoppers versus our more infrequent customers? There are all sorts of ways of answering this question, but here's how we can use vibe categories to help us. First step is preparing our data for the AI LLM. To that end, what I've done is I've taken a random sample of 400 customers. I then took all of their transaction totals for transactions over the course of a month, and then I took these transaction summaries and placed them in a single field I'm calling transcode. For each transaction that is a sale, I take the total amount sold and add it up and prepend the letter S to signify it as a sale. If the transaction is a return, I take the total amount returned, add it up, and prepend the letter R to signify it's a return. So here's what the data looks like. Now, if we scroll the list of customers, and we can see that there are some that are quite frequent and others that are infrequent, and if we look closer, we can see that our customers and their totals and transaction types are fairly consistent, while for others, they're a bit inconsistent. This kind of bottom-up scanning is helpful because it gives us a sense of what kind of category structure we might want to ask for. In this case, we've already figured it out, so I'm going to go ahead and author the AI prompt for writing my vibe categories. All right, step one, we open up CoPilot, and step two, we paste in our prompt. And then step three, we bring in our data file. And then we hit submit. It's asking if I'd like a brief summary of the categorization logic before I finalize the classifications. Sure, why not? Let's just say yes. Okay, that looks good. I think I'm okay with all of those assumptions. I know I'm scanning quickly, but they all seem to be fine. So I'm going to say no, I'd like to proceed. And it's going ahead, and I guess we just have to play the waiting game for a few seconds for it to process. Okay, so after a short wait, we now have our file. So let's open it up and take a look to see how we did. Now we can profile it here in Excel, but I actually prefer to use another tool called EasyMorph for data profiling. And EasyMorph is a data preparation and analytics tool. This is actually a free trial version, and it has quite a bit of functionality. So I'll be using that for the remainder of this demo. So I'm just going to drag that same document into EasyMorph, and we're going to jump into what's known as analysis mode. So I'm just going to widen the columns a little bit, and then I'm going to pull out the 4 categories. And you can see here right off the bat, so we've got 400 customer records, And we can see how many customers sorted into each category here. So 184 into consistent frequent. And then at the bottom, we've got 11 in the inconsistent frequent customer. So now the next step, and this is kind of the most important step, is to determine whether this categorization is actually fit for use. Now, in our case, we have a fairly high tolerance for error here. So, even if I find a few exceptions, I'm not going to stop that from this demo here. So let's look at the inconsistent frequent customers. And so these are fairly frequent. There's quite a few transactions here, and we can see they kind of go 1,000, then dropping down to 30, 42. So that does look kind of inconsistent. That does look kind of frequent. Let's go and look at the inconsistent low frequency customers. This one here, I would almost put this into more frequent, but again, doesn't have to be perfect. And then consistent low frequency customers, most of these look like there's not very many transactions, so I'm okay with that categorization. And they do look relatively consistent in terms of their transaction amounts. At least there's less variety than the other bucket we just looked at. And then finally, there's consistent frequent customers. So these are customers that have a lot of transactions, and they are, for the most part, relatively similar. Again, I think this is fit for use. I could probably debate this a little bit, but for now, I'm okay with it. We are now at the final and most fun part of the exercise, which is analyzing our new vibe category. And this is going to help us settle our original debate, which was how do we allocate budget for new versus existing customers? Now, I've already prepared this EasyMorph project for doing this analysis. So let's walk through that and finally answer our question. So basically what I've done is I've taken this transcode here and I've split it into rows. And then I've separated out the returns from the purchases. And I basically now taking those returns and making them into negative amounts. And then finally, I'm just adding up the total transaction amount for each customer. And then over here, I'm basically taking that customer list and I'm calculating the average of each customer. And then, of course, putting them in each of these respective buckets. So this basically shows us our answer over here, although I've plotted on this chart here to make it a little bit easier to interpret. So you can see way out ahead, the consistent frequent customer, it looks to just eyeballing it here at least a factor of, I'm going to say 4 or 5 versus the inconsistent frequent customer. And then we have down here our low frequency customer. These would be more like our new customers. So the gulf between I would say the loyal customer, and this is something what I would call the loyal customer, and the unloyal infrequent customer, for lack of a better term, inconsistently low frequency, is huge. And so just again, now we can quantify this some more, but I'm going to say that we would want to spend at least 2 or 3 times as much on retaining existing customers than hunting for new ones, because they are just so much more valuable to us. And that basically concludes our analysis. Summing up, we were able to accomplish a categorization exercise in just a few minutes. We can keep vibing here if we want. For example, we could categorize customers based on the types of items they tend to purchase into, let's say, grocery regulars versus hard good regulars. Analysts have always been able to derive categories, but typically only simple rules or decision trees type of categories, which themselves can be actually quite time-consuming to develop. With generative AI tools like CoPilot and ChatGPT, a whole new horizon has opened up. But these vibe categories, in my experience, are very hit or miss. You might get lucky and stumble on a vibe category that reveals something truly hidden or powerful. But where I see the most high-value application for AI categorization has less to do with these vibe categories and is more to do with aligning existing category structures within the same organization. So that's what we'll get into in the next video. In the meantime, goodbye.